employed. We have Richard Branson. His source of wealth is not just from one business alone. He has about 7 businesses that rakes in millions of naira for him. So I believe you don't just want to be someone that has only one source of income. Even in the Garden of Eden, like we said, there are about 4 rivers watering that land. So please, I want you to take this very serious. And that is why you have access to my YouTube channel. If you watch the replay of the videos and you don't understand anything, drop your comment in the YouTube comment section. I'm always online 24/7, except otherwise. I will reply. You have access to the WhatsApp. Drop your question. I will reply. On my LinkedIn, I'm following you guys. So immediately you post something related to this, I talk about them. So please, I want us to take this thing very serious. I hope I have come.
Sir, thank you very much. Like, we really, really appreciate this offer and you taking out your time to enlighten us.
Okay.
We're really grateful.
You are welcome. So let me quickly go through a slide. So the slide will be like a refresher of all things we've talked about. The idea today is that at the end of today's class, you should be able to size the appropriate inverter for your home or for anybody or for your department, or maybe there is a session in the department in your school and they are trying to get an inverter system. At the end of today's class, you should be able to size the appropriate inverter for them. Are you happy to hear that? So your house today, at the end of this class, you should be able to size that, oh, this is the size of the inverter that will be good for my home. This is the appropriate size that I should buy. Is that not interesting? So at the end of today, you should be able to do that. So let's get started. So I'm sharing a slide. So the slide is just to lay emphasis on some of the things we have discussed about. I believe you can see my screen now. So you have there energy auditing, right? Let me be sure you can see it.
We can see us.
Okay, so I have put it in the presentation mode. So let me quickly do a fast one. So energy auditing, beautiful. Now, this is where we are going to, but we are just here. We are in the inverter session. We are still here. We are still here. We are still here. We are in the inverter session. We are still going to talk about the solar panel. We are still going to talk about the breaker. We are still going to talk about the charge controller. We'll talk about the batteries. The load is what we are talking about. So you can see the loads. You can see the loads. For loads, we have DC loads. We have AC load. Now, this router is receiving a DC power. Apparently, the charge controller has a LAN connector, and the router is connected to it to serve the laptop and the desktop with internet facility. You also have the inverter. So this load you can see is called the AC output, which shows that these are the DC load. Sorry, these are the AC loads. The AC loads are the loads you connect to the inverter. You can't connect the DC load to the inverter. It won't work. But some charge controllers have the capability that you can connect the DC load directly to them. So if you don't have an inverter, you can still power your light bulb with the PV, charge controller, and battery. But now we are talking about the inverter, and we are concentrating on the load because these are important parts of the system. So the learning outcome is to understand energy audit and the type, developing load profile, types of load. These are what we'll be talking about. I've explained to you that we have the walkthrough audit, which is like a preliminary audit, an audit whereby you go to the client facility to just take notes. You have your jotter, what is on, how many do you have. But in a detailed audit, you go with tools, sophisticated tools to take measurements. In a preliminary audit also, you can take some tools, but not sophisticated tools, just some light equipment that does not really take a lot of great energy to use, like a loss meter. Maybe you want to know the light level of the room. So it's a small meter you can just put in there. But for a detailed audit, you are ready to use equipment that will give you a good calculation with minimal error. And that is what you do in detailed audit. Okay, so to obtain power rating of our appliance, I've explained it. I said you can do direct reading on the nameplate. So all the stickers, when you buy any device and you can find sticker in there, all what you see there, that sticker is called a nameplate. So the information about the device can be gotten from the nameplate. You also have direct measurement of voltage and current using a multimeter. Now, you can also use multimeter to do slight measurement. Reason being that, imagine you can't find the nameplate of the device. You can't, you are not sure. So with a multimeter, you can measure the voltage going into it. But most importantly, I will also put in there a clamp meter. With a clamp meter, you can put the clamp meter in between the cable. And when you do that, you can have the measurement of the load of the current going through the cable. Then you also have direct measurement of energy consumed using an energy meter. So the energy meter, we are talking about the sophisticated energy device. Like I said, like the FRG meter, you have the Fluke brand of the energy meter. So these are important things you need to know. Somebody said, please, do you have the pictures of this meter? Yes, in the next slide, you can see that. So look at the clamp meter. So this is the clamp meter. This is the clamp meter. So how do you use the clamp meter? To use the clamp meter, imagine this is a cable. So you have the cable and you put the clamp meter around this cable. Can you see? So because this side of the clamp meter has a magnetic sensor, it's like a solenoid. You have a magnet with copper or wire wounded around it. Then with that, you can measure current flowing through this wire or cable. So if you get the current flowing here, current I, and the voltage is single phase voltage, that's single phase, one phase. The voltage in Nigeria is about 220 to 240 volts. In other countries, volt AC now, alternating current. In other countries, their voltage is 110 volt AC. So when you travel to other countries that use this, you may need to get an adapter that can convert, that can help you to utilize this 110 rather than this. Because if your device is operating at this, so you need something to help you to convert this voltage to 110. So if you can measure the current, imagine you have a fridge that the nameplate you can't get anymore. So if the cable that goes from the fridge to the wall socket, so you measure the current from the current going in there, or any device. So far you have a live and neutral. You measure the current, I, the voltage is 220. So, and you know that your power is what? IV. So the current you measure, let's say 2 amps, multiplied by the voltage, which is 220. What do you have? You have what? 440 watts. So that's how you utilize this clamp meter. It's a very important tool. Then this is a digital multimeter. It's a small one. And you have, these are some other type of multimeter. These are another type. So it depends on the quality. Some multimeter can measure current too. This can only do up to 10 amps, as you can see. So if you measure 20, it may burn the fuse in, it will burn the fuse in the meter. So this is 10 amps. Okay, these are energy meter. They are facing out all these electromechanical meter, but these are smart meters. You can measure your electricity consumption also. So another way to do that is if you know what you consume daily from your electricity bill, then you can use that also in sizing your solar system. So I believe this is clear. Thank you. So the energy requirement of an electrical system depends on the load. So that's why the load is an important part that we are looking at. Electrical loads are in various types. I told you we have resistive load. Or your light bulb, they are resistive. You have capacitive load, capacitor and the likes. You have inductive loads, transformer, generator, they are inductive loads. So however, so the thing is, some of this equipment is a water pump is an inductive load, SC, inductive load. They draw large starting current, which could be up to ×5 of their normal current, operating current. Maybe the operating current is 2 amps, normal operating current. But at startup, it can take ×5 of it, and that's 10 amps. But these 10 amps will not last for so long. It can be for half of a minute. That's about 0.5 seconds. It will, within 0.5 seconds, it take these 10 amps and go back to the 2 amps, which is the normal operating current. Okay, so this high starting current only lasts 0.5, like I said. So other loads such as water heaters, electric irons. So I can see that some of you have made your table, but you put electric irons, boilers, and electric kettle and like. So I ask you to remove this. Yes, it's not solar can power this, but when you are looking at the investment cost, so you want to leave this out so that because the cost will definitely increase. But if you have an high-end client that is ready to pay the money, you can actually do that. Okay, so for capacitive loads, for example, let me just use the simplest one. You have a capacitor. So these are loads, they store charges. So you discover that sometimes you have a load, your remote, even after you see the infrared light still on, because you have capacitor that stores charges, and it takes a little bit of time. That is why when you are doing any electrical work, after shutting down, it's advisable that you relax a little bit, especially if the electronics component, because the capacitor can still store energy, and you also want to be very careful. Okay, so we talk about load. Look at this load: incandescent, CFL, LED light bulb. Now, the wattage of this is 60, this is 18, this is 10. You would rather go for this, which is very important because this is 10 watts. Another thing is the lumen. This is 840 lumen. The lumen has to talk about the brightness of the bulb. Imagine this is 840, this is 825, this is 800. You can see there's no really big difference. If this is consuming 60 watts and I'm having 840 lumen, why can't I go for something with 10 watts that still gives me 800 lumen? So this is what you look out for when you are buying light bulb. Life of this is about 0.9 years. This is 22.8 years. So you really want to look at this. Let me put this in terms of, let's say, months. And let's say this is 9 months. Let's say this is about 2 years, so to say. Estimated annual energy cost. So you can see this table is letting you know that it's better you go for LED light bulb. For some of you, you've complained that you buy LED light bulb and they get destroyed immediately. Now, what you need to understand is that for your LED light bulb, this side there is like the sink. It is a very important part of your LED light bulb. So ensure that you buy an LED of good quality, an LED of good quality. So an LED of good quality may come as a cost of up to 2,000 naira. How many of you want to buy a bulb that is 2,000 naira? You rather go for 250 naira, 300 naira. But if you get this, you are sure that it will last for a longer time and you will get value for your money. Okay, so some AC loads as CFL and motors have a very poor power factor. I've explained what power factor is. Power factor is what? Is the real wattage divided by the what? The apparent power. So the real power divided by the apparent power. In the LinkedIn post, I saw an error from someone who posted it. I really appreciate that because it shows you are showing that you are following the class. So go and look at it again. The apparent power is square, is the Pythagorean sum or the vector sum of the real power, the square of the real power, and the reactive power. So you can go back, look that, and make your correction. So this K var reactive. This small letter K. If you put small letter K here, you need to put small letter K here and put small letter K here. You understand? But if you don't put K here, that would just be VA square, watt square, and what? VAR square. I hope you are following, guys. Okay, so standby power. I explained. Do you have any?
This last explanation is kind of confusing.
Okay, so let me explain again. Okay. Let me explain again. Okay, you know the last time we talked about the different types of power, and I explained that using the beer analogy. So let me continue. So I'm going to explain that. I'm going to explain that. Okay. So let me explain that. So for the power factor, this is the formula. The K var is the apparent power. It is the vectorial summation of reactive power and kilowatt. So you remember this. I don't know if any one of you went to YouTube to look at this. So look at the beer.
Yes, I remember that.
Yeah, so can you see the rib here? This is the rib here. This is the foaming part. We call it wasted electricity, but you can see it in quotes. It's not really a waste because in electric motors, because of the magnetic flux, you use it to overcome tug in the machine being able to work. So you have the usable electricity. So the usable electricity is the repair, which is the kilowatt. Kilo means 1,000. K, kilo. So if I say kilowatt, it means what? 1,000 watts. You get that? So this is the kVAR, reactive, VAR, reactive power. So I told you there are three types of power in electrical system. You have the real power, you have the reactive power, and you have the what? Apparent power. So the apparent power is if you have a triangle, a right angle triangle, the hypotenuse is, so like I'm saying, I have the real power here. So the hypotenuse, this is VA, which is the apparent power. This is opposite. You remember SOHCAHTOA? You remember SOHCAHTOA, GS3? Yeah, so SOHCAHTOA, if you have this right angle triangle, you have the hypotenuse, you have the opposite. So the opposite part is the reactive power, VAR, volt ampere reactive. The hypotenuse is the volt ampere, which is the apparent power. Why the adjacent is this part, is the true power. So imagine, so if you are looking for VA from Pythagoras theorem, you know, A square equals to B square plus C square. Now, A square is the longest side, which is the hypotenuse. So you have VA square equals to what? Real power square plus what? Reactive power square. So if I remove the square here, it will convert this to square root. So my VA now will be equals to what? The square root of W square plus VA reactive square. So is that clear? So that is the essence of what. So the K you are saying means 1,000. You have kilo. K means kilo. That's 10 raised to the power of 3, 1,000. You have mega. Mega, 10 raised to the power of 6. Abi? You have giga. Giga, 10 raised to the power of what? 9. And so on. So did I answer your question, okay? Or do you understand now?
Yes, sir, I understand better now.
Okay, beautiful. So let's go on. So I end this slide here. So this is just for our understanding. If you go online, you will still see, it's called the Beer-Morgan analogy. The Beer-Morgan analogy. Okay, so now what I want to do is, I want to share another screen. So doing that now, I want to share the Excel sheet we have both been working on. Okay, so let's go back to this. Someone asked me a good question, and I want us to pay attention to this. One of you asked me a very good question. I want us to pay attention to this. Okay, so let's get, so you still remember this table, right? So this is the table we have been working on. So let's quickly look at it. So we have our apparent power. I have my surge power here. So the question goes thus. The person said, excuse me, sir, if I have a load, let's say a computer or an electric kettle that I don't use often, maybe I use it for 3 hours in a week, I use it for 3 hours, and I use it maybe on Monday, Wednesday, and Friday. Imagine, that's about 3 times in a week. That how will it quantify the hours of usage? And remember, we calculated the daily energy by doing the surge, by doing the apparent power, the apparent power multiplied by the hours of usage. 300 times 5, 1,005. So because of that posing question, and I included a computer now. So days per week. So I included another column. So imagine I have this computer. I use it for 5 hours in a day. I use it for 5 hours per day. You get that? I use it for 5 hours per day, but I don't use it every day. I use it like 5 times in a week. I use it for 5 times in a week. So how do I do that? If this has been 7 days, 7 divided by 7 is 1. 1 times 5 is still 5. 5 times 300 is still 1,500. If I put 7 here, 7 divided by 7 is 1. 1 times 5 is 5. Times 300 is still 1,500. But now, I'm using it for 5 times in a week, and I'm using it for 5 hours. So what you do is what I have done, which is to put another column. So what I do is my hours now will now be these hours of usage in a day, 5, multiplied by, I have 7 days in a week, and I'm using it for just 5 times in that week. That would be 5 divided by 7. So I have 25 divided by 7 hours. So multiply this 25 divided by 7 by 214, and you have 764. So if that person is here now, so I believe he can get the answer to his question. Any questions so far? Hello, any question? Anybody? You want to say something? You have questions to ask?
You multiply 5. Okay, if you multiply 7.
What do you say?
You said that when we divide 25 over 7, what do we multiply it by?
Now, because what you want to get is the daily energy, and the daily energy is the apparent power multiplied by the hour. So this is the apparent power, 214. So you are multiplying it by 214, which is the VA, multiplied by 5 times, because I'm not using it for 7 days in a week, I'm only using it for 5 days, and I have 7 days in 1 week. So 5 over 7. So you do this mathematics, you get your VAH, which is 764. So like this one, I do not put 7, because even though if I put 7, if I do 7 divided by 7, it's still 1. 1 times 5 is still 5. 5 times 300 is still 1,500. So because of the person who asked that question, I have to bring this in because it's a very important question. So I hope there is clarification for this going forward.
Yes, sir.
Okay, beautiful. So we are done with the table analysis now. If you are followed me succinctly and you get the picture of this table analysis, I tell you, you have started the inverter business, so to say. Because the number one thing is to do an accurate table for your analysis. Remember, this is a walkthrough audit. You can have a detailed audit, but walkthrough audit is also what is obtainable. We use it, abuse it. A lot of people are using it. Some people don't have money for those sophisticated equipment, so they rely on this walkthrough audit and try to make sure it is accurate as they can. So if you get this table perfectly, I tell you, you don't have any problem. If you look at it again, if you have any challenge, remember this power factor, we use 0.7. Some can be 0.6, some can be 0.8, but if you use an average of 0.7, you are fine. So if you do that, you have the apparent power. If you do that, you have the apparent power, which is like you already have the formula. The apparent power is the total wattage divided by what? Power factor. So if you do all this divided by the power factor, you have the VA. And the interesting thing is that to size the inverter, we need to know the total VA. And that is the essence of all this we have been doing. Okay, I want one or two persons to comment on this before we now go to not the last session for today, but the critical part of today, whereby I will now explain how you can now use this table to get the accurate inverter size for your load. Abdulzai Alao raised his hand. Please unmute yourself and let's hear you. Thank you.
Yeah, good morning, sir.
Good morning.
Yeah, sir, I have a question.
Yeah.
Like, for example, the ceiling fan and the LED lights. So how do we, most ceiling fan and the LED lights like we get in this Nigeria, it might be substandard. So it might actually be that the power rating is actually more than as it is advertised. So do we factor in like excess, like probably you should add more because it might not be what is on the carton or something. It's 15 watts, and it might actually be that it's consuming 20 watts. So how do we factor all this in? And also if you want to use some appliances that you don't use every day, maybe blender and some other pressing iron and all that you don't use regularly and all that. So how do we factor in all that into the calculation?
Okay,
Thank
so that is exactly what I've been explaining, but let me just recap again. You mentioned a good point. You said because of the inefficient or depending on the quality, that it can be a bulb can be rated 15 watt and in actual fact, maybe it's consuming 20. The problem is because of the power factor. So let's do this now. VA equals the real watt advertised divided by power factor of, let's say, 0.7. What is 15 divided by 0.7? Abdul, are you there? Allow. 15 divided by 0.7. Anyone? 15 divided by 0.7.
Yes, sir. 21.
So can you see? 21 watts. So you are actually right.
Okay.
That's the essence why we are putting all this power factor into it. Now, to your second question, that's why I introduced this computer in here. Now, the VA is 214. So depending on whatever load, imagine I'm using it for 5 hours and I'm using it for 5 days in a week. I'm not using throughout the week. I'm using it for 5 days in a week. So what I can do is, because the 5 days is not up to a week, so I have to do a ratio. So that would be 5 divided by 7 times the number of hours I've been using it in that week. So whatever I get here is the hours of usage. Then I multiply it by the VA and I get my what? 764. Is that clear?
Yes, sir. Thank you, sir.
Okay. Any other person, any other question before we go? Any other question? Any other question? Okay, if no question. So let me open another slide. I want to be sure we are all on the same page. Any other question? If no, let's just move straight to the next point. So I'm sharing my screen again. Okay. So are we together? Can you see my screen?
Hello, sir.
Yes,
Yes.
we can.
Okay.
So, did you get my question?
Okay, let me check. I did not get your question. What was your question?
Okay, I said that like some appliances, like let's say an iron,
Yes.
if the sticker isn't present again,
Yeah.
how do we get the surge power? I mean the surge factor. Because you said that it's usually on the sticker, the information, the surge factor, and everything.
Okay.
So how do
So
we go about it? Like if we don't have the manual also?
okay, so for any device that you are trying to get the power and you can't get it, for instance, if the electric iron, the name is Philips, maybe you don't have any area to get the information. What you get, if you can get the name or the code, just go to Google, your friend, 6-letter words. That's the most lovely 6-letter word. Google, put in the name and the brand. You will most likely get the data sheet on the internet, which gives you a lot of information about the product. So if I share, so for example now, let's say you have a Panasonic, so whatever the name is, or sometimes I want to see the manual of a particular equipment. Maybe I don't have the manual. I can take the name, the brand, put it on the internet, and before you know it, I have the manual that gives me a lot of that information. Is that clear?
Yes, sir. Thank you very much, sir.
Yeah, you can try it out and you will see. Just pick a
All
random,
right.
even if you have the manual, just pick it and do as if you don't have the manual. Put it on the internet, you will get the accurate manual. Okay, so inverter sizing, beautiful. Now, take note of this bullet point I've put in here. I call it inverter acceptable tolerance. It's a very vital factor which we are going to be using. Inverter acceptable tolerance. Like I said, at the end of today's class, you should be able to comfortably size the inverter for your home. For anybody, you should be able to go to your government house. Or yeah, anybody, I say anybody, go to their apartment if they give you access, do your walkthrough audit and size the appropriate equipment for them. So for the detailed energy audit, if you have to use the power meter, it may require some expertise to know how to use those meters. So, but this walkthrough is something you can do yourself. If you need to use the power meter and you don't know, you can take somebody who knows how to use it along, and you guys, you do it together and you measure the energy consumption. So now we want to size the inverter. All the information we need for sizing is what we have seen in the Excel sheet. I believe you also have your own in your notes because I believe you are taking details at home also to be able to see what we are doing. So I already have the loads that I have done. So we are going to use that now to size the appropriate inverter. Please take note. You remember from the table, we have our VA and we also have the surge power. So I want to be sure that we are all on the same page. So if you look at this screen now, this is our total apparent power, which is 978. It's a very great value for me. I need it because it's the VA. This is what I need to size my inverter. But also, look at this surge. All the others doesn't have surge, but this fridge has a surge. Why? Because we have assumed that the surge is multiplied by 3. So we assume that the surge is times 3 of the initial consumption power. So that's why we say 214 times. If we have assumed 5, So we should have used 214 times 5. So, but we are using 3. That's how we add 642 VA. I believe we are all clear with that now. So this is the apparent power, this is the surge. So how do we now use this one, these two, to size the appropriate inverter? And that is what we are going to be looking at now. Okay. So I go back to the Word doc that I opened initially. So look at this again. So I have design information. Inverter acceptable tolerance is 20. What does this tolerance mean? Somebody. What does this tolerance mean? You remember when we are in school, we are still in school actually. School life is a school, so we learn every day. When we are staying in junior school, you have some kind of mathematics whereby you say increase 100 naira by 20%. You remember those mathematics? Increase 100 naira by 20%. Let me tell you the long way that people do this. People will say, oh, let me find 20% of 100 naira first. And that is 20 naira. Abi, you remember, did you do yours like this? Then you now said the increase will now be, or the total will now be 100 plus 20 naira. So that means your answer is 120 naira. But now, what we are saying is, if I say increase $100 by 20%, the best way to do this is to do this, because this $100 is like you have 100% of it. You have it at hand, and you are increasing it by 20%. So that's more like 100% plus 20%, which is 120%. And 120% is what? 120 divided by 100, which is 1.2. So when you are doing something like this, is you can say 100 times 1.2, because this 20%, you are increasing it. That means you have 100% earlier, you are adding 20% to it. That's 120%. 120 percentage is over 100, so you have 1.2. So 100 times 1.2 is $120. So can you see, fast method, this is a long one. So anytime you are, if I say increase 50 naira by 70%, what you need to do is just to say 50 times 1.7, and that's your answer. So so is that clear? So get that and get that very well. So now, so what we are going to do now is so we have that the inverter tolerance. So what does tolerance mean? Oh, maybe my load is about 50 or 500, and I want to increase it. I'm saying that in the future it may increase, but I don't know how much it can increase to. So I'm saying I'm increasing it. So instead of doing exactly 500, I'm increasing it by 20%. That would be 500 multiplied by what? 1.2. And that will give me, if I do 500 times 1.2, that will give me about, is that not 600? So that means I've added an additional 100 to the 500. So that's the essence of the tolerance. So we are doing a 20% tolerance now. So now let's move. So I have calculate the total power and energy using a load analysis worksheet. You already have the worksheet. Please note, you already know that the power factor is what? PF. Apparent power is this. VAH is the energy, which means volt amp hour. So now what we are trying to do now is to be able to calculate the inverter size. So the same thing still apply. Look at the load, but now you already know this table. So look at my apparent power. This is another table I have. My apparent power is 825. My surge is 642. So how do I know the required inverter size? So this is the formula. So my required inverter size is given by my required inverter size is given by the total apparent power multiply plus 20% of the total apparent power, because I'm increasing, because the tolerance says 20%. So that means I have 825 here. So plus this tolerance, 20% of the apparent power. So 20%, that would be 825 multiplied by 1.2. So I'm adding this to this. So if you are following me, 825 plus 20% of 825, that is 825 plus 165. Required inverter size is 990 VA. But I can't, if I go to the Nigerian market, I may not see a 990 VA inverter, but I can see a 1000 VA. So the continuous power recommended inverter size, continuous, that means when all the loads are on, is what? 1000 VA. 1000 VA.
So what's the lowest size of inverter that you see in the market?
Oh, beautiful. I like this question because it's bringing about, it shows we are improving, and it is bringing about a lot of curiosity. So in the Nigerian market, you can get, the lowest you can see is 300 VA. Some people will say 300 watts. But I believe you should know the difference. Now, if you don't know, let me quickly show you. This, if you see 300 V equals to 300 watts, that means they are saying the power factor is 1. Because if you do VA equals to watt over power factor, then you have 300 divided by 1, which is 300. More likely, that would be in an ideal situation. And you can't have an ideal situation. You get? So some devices are very good. You can get up to like 0.96. That means there's a little loss of power. So, but if you see 300 vehicles to 300 watts, that means something is to be done. So basically, that is how you size your inverter. And that's all. That's your inverter size. Your inverter size, the least you have is 300. You can see 500. You can see 800. Are we together? You can see 800. You can see 1000. You can see 1200. You can see 1500. So you have different types actually. So now we can see that continuous power is 1000. So you can see that I said 1000 VA, and I've told you kilo means 1000. So that's why I changed it to 1 kVA. So most times you hear kVA. So inverters are rated in kVA. So this, how do we now consider the surge power? The surge power for the fridge, if you remember, is what? 642. How do we now factor this surge into this calculation? So let me do something for you now. Look at the screen. I want to do something. That means, pay attention, please. That means if I start up this inverter, which is the 1 kVA inverter, look at what will happen. If I start up all the loads at the same time, look at what will happen. That means it will consume this, it will consume this, it will consume this. Instead of consuming this, it will consume this. Do you remember? Or do you agree? Why?
Yes,
Because,
sir.
yeah, beautiful. Thank you. You are following me. Because this is a continuous power. But because the fridge will take a surge, this is what it will consume. So to know the total surge now, you will add 300 plus 100 plus 204 plus 642. So look at it, 300 plus 104, plus 107. So I said the surge power of the fridge is 214 VA times 3. That is 3 times. The power supply must be able to provide a continuous power. That means when I put on all the loads, I should be able, the continuous power should be 300, 107, 204, 214, which is 825, right? But by the time we look at the tolerance, which is 20%, we got 1 kVA. That means it should be able to provide a continuous power of about 1000 VA. Why the power supply must also be able to provide a short-term supply of 611 VA, which is 3000, 107, remember, 204, and 642, which is 1253 VA. So for how many seconds? 0.5 seconds. I am putting on everything because of the surge inclusion. So the continuous power is this, but I have 1253 VA to provide for short. So check the manual of your choosing inverter to confirm it can supply the surge power of what? 1253 VA for what? For 0.5 seconds.
So you're saying that in an instance where an appliance has a surge factor, has a surge power, I mean,
Yeah, good.
instead of taking the other power, will calculate the surge power instead for any
So
appliance that has a surge power.
yeah, so for any appliance that has surge power, consider the surge also. Because if you don't consider the surge, if you put on everything at the same time, the inverter may say overload. It may give an indicator by saying overload because that means you've not sized it appropriately. So you must be able to size it accordingly so that you can cater for the surge power also while sizing the equipment. Any other question?
Yes, sir.
Yeah.
Like sometimes now, maybe because of cost of setting this up,
Yeah.
like sometimes we may not, like in my house now, the inverter we have is not sized for our house. So, but we had to make some alterations, maybe so that maybe in some sockets, like socket connected to fridge or all these things, such that if power goes out, the power from the inverter will not continue flowing to that socket.
Yeah.
But I want to ask one question, like when the like NEPA now, when the thing goes out, when NEPA goes and you said continuous power is to flow and there's normal continuous power to the appliance. When it switches to the inverter, does it use such power at that moment?
It depends on the load being connected to it.
Okay, like let's say a water dispenser now.
Definitely, it's going to take a surge.
Okay. Thank you, sir.
Yeah. Okay, any other question? I believe by now you know how to size an inverter now. So there's this table I want to show you. I'm actually looking for it. So the table we show you is a typical inverter manual. So which was showing the surge. It was showing the surge power of the inverter. So I want to see if I can quickly show you that for today. So, but if you have any question, please bring it in. Hello, are we together?
Yes, sir.
Any other
Yes,
person
sir.
with question? You have question? Let me see if I can quickly share this. I
Yes,
think
sir.
it will go a long way. Let me quickly share. Yes. I think I can share it in 1 minute. Okay, this is it. So look at this. If you can see the screen.
So someone asked the question in the
Okay, so I will look at it now. So if you look at this is an inverter manual. Look at the surge rating. Look at the rated power. If you can see, the rated power is 400. The rated power is 400, but the surge power is what? If you can see it, can you call it? The surge rating is what? Can you see it? The rated power for this is 400. In the manual,
chat box.
the surge rating is what? Did you
It's
see it?
700.
Huh?
Okay, the surge rating is 800.
Beautiful.
800 watts.
That means the surge rating of that inverter is ×2 of the continuous power of 400. You understand? The rated power. So we can also use that as the continuous power it can take. So you can see. So like the inverter we choose the other time. So there's this inverter here. It's 1000 watts. That's the continuous power. What's the surge power? The surge power is 2000. So that means I can actually select this inverter because my surge is about 1200 and something, right? And I'm told that I can take a surge rating of 2000. So this is a perfect fit for me.